Okay, welcome to the class. Two basic requirements, coding skills. Um, I'm not asking you to know Swift or Xcode, Python right now, but Python, maybe Python, okay language for you to get familiar with. So in any language, if you are okay, then you will be okay in this class. And also device, that is another thing. MacBook is the best. If you do not have a MacBook, then you need to come to the campus, either Manhattan or Dobbs Ferry. Then we have a MacBook, totally designated to this class. So you can, if you come here, then you can work on it. Either Dobbs Ferry or Manhattan. All right, syllabus. I know this is in-person class, but sometimes as planning, or sometimes because of the weather issue, then we may meet virtually. Sometimes we can plan. If we plan it, I will let you know in advance. If there is any emergency issues like weather, then you can hear something from the university. All right? Or because I have your phone number, yes. Hopefully the phone number that I received from you guys is the phone that you usually check. This is not home phone number, right?
No.
This is not the number that your home country is. So that I can contact you, right? Hey, go back your home and turn on your Zoom. Then we can meet that way. Okay. Basically, this course covers two things: sensor technology and apps developments. Because we will do multiple small applications to develop, starting with the simple ones. Only on iPhones. We're not dealing with Android phones in this class.
So we have to have an iPhone?
You don't need to, if you can, that is perfect. But Xcode provides you the phone emulator. We're going to use that phone emulator a lot while we are developing. So we do not really deploy your iPhone app on your real device. You can do that if you have iPhones. But other than that, emulator is fine. Only the drawback of using the emulator extensively is the performance issues. If your MacBook doesn't run so fast, then you have Xcode running and you have emulator. Emulator may take long to visualize. Lots of refresh the visualizations. So that is potential issue. Other than that, I think emulator works. My MacBook runs M1 processor. Currently, there's an M2 or M3, right? So a lot faster, high performance. But mine is maybe lower among ourselves. So if my MacBook works okay, then you guys' MacBook presumably runs well. sensor data collections, we are going to use Raspberry Pi. That is another device. Raspberry Pi is not really expensive ones. I'll introduce you guys. Raspberry Pi current model is P4B, P4. Let's see. Pi 4 Model B, so it is called 4B. This is Raspberry Pi. You can acquire this directly from Raspberry Pi, or Amazon has lots of Raspberry Pi versions as well. So if you go to Amazon, Raspberry Pi and sensors, if you type that, then you can get that very quickly. So one of the things is here. This item has lots of sensors. The motion detector. I want you to buy one time so that you can do something okay, right? But be careful, this guy does not have a Raspberry Pi, right? Only the sensors. But if you go somewhere, then the bundle version of the items that you can use. This is a camera. Or if you say without sensor only Raspberry Pi, then you may be able to see more. These are a little better models. If I see here 64 bits Wi-Fi and 4 gigabytes main memory. The smaller one is 2 gigabyte. Look at here, 8 gigabyte, then over $100. Of course, this guy has SD card. This is the Raspberry Pi, and fan, and then some of the chargers. Before we had COVID-19, 8 gigabytes was half a price, but doubled during the past 3 years, which is no good. But anyway, that's what happened here. So 3 years ago, we purchased $60 or $70, but right now $150. 8 gigabytes RAM, that is too much. But if you want load a lot more, then 8 gigabytes still good to go. If budget is the issue, then I want you to buy 2 gigabytes. This is 4 gigabytes. 2 gigabytes is still perfectly fine. What is it, 2 gigabytes? If you have Model 3 Model B, that's still okay. This is the old version. If this is $49, this is really ripped off. 3 years ago, this model is about $10. Right now, $50. This is a discontinued models. Please do not invest your money on this. This is a Raspberry Pi, but Pico version or 0W versions. There's a lot of restrictions. Please do not try with this, although this is cheap. You guys need USB and Ethernet. Ethernet optional, you don't need to do usually. But sometimes I use this Ethernet port. If you want to make your own Wi-Fi device, then you can use the Ethernet cables, so that this will run your Wi-Fi router. If you run your Wi-Fi router on your Raspberry Pi, then guess what? You can catch all the packets very nicely. This is for the hackers. Computer scientists doesn't do that, but cybersecurity professionals will do that. But anyway, so those are the Raspberry Pis. So again, 2 gigabytes Raspberry Pi for Model B will be enough. So that should be lower than this amount. And also sensor, you don't need to buy sensors right now, but you guys do not know what you want to do, right, for your project. Are you going to use the sensors? Are you going to use the actuators? Are you going to use both of those? Are you going to include iPhones? iPhone has the sensors as well. So a lot of variations. So do not make a quick decision at this time, right? Too early to make that decisions. Okay. I want to skip all others, but something that you may like here. As I said, Raspberry Pi 4B, 2 gigabytes or higher. But anyway, 4 gig is the minimum. So I wanted to buy this. iPhones, only on your own use. Phone on iOS. If you're not a person subscribing iPhone, fine, you don't need to buy. But as a developer, this is a must buy. Other than if you do not have MacBook, some difficulties. If you do not like MacBook, but still wants to develop, there is another option. Then you can subscribe Apple Cloud. So Mac in Cloud, so-called Mac in Cloud. Let me show it to you. If you go to Mac in Cloud, there's a rental Mac in the cloud. Yeah, this is basically what it is. So you can develop yours here. It provides you Xcode, so you don't have to worry about installations. But only the issue here is, here's an M2. So you are using M2 process because you don't need to buy, right? Only use by paying. I do not want you to subscribing. If you want to work on Mac in Cloud, do not subscribe annuals because you do not know how long you are going to use. I don't want you to do by minute or by hour. You do not know how much that you're going to work, right? I want you to buy monthly, okay? Monthly. How many months? I would say at longest 3 months. Okay? So you can start, if you want to subscribe Mac in Cloud, start from mid or late February. So March, April, and mid or late May. 3 months enough. I think it is about a little bit over $20 per month. There's another option that you can use. That is only the requirements other than the coding skills. This course does not test any written exam, only homework and project. Okay, no test, no exams, but many homeworks. The way that I ask you to do your homeworks is the completion of the work that I am doing here in class. Why? Because I do not give you, class doesn't rate you, each of you complete all the codings. Many times, course should move at some pace, right? That way, course can cover everything that we originally planned. Everything will be recorded and available on your Blackboard, so you can replay and retry, practice a lot. And homeworks usually do completion of the class XYZ. Then that is a homework number 5. Then you need to complete it, okay? So I do not want you to be frustrated at all during class, although you do not follow. Of course, it's almost impossible to follow during the class. If I am students, I probably cannot do anything. So you simply listen, see if how I do here. Everything is recorded. So you can take your time. You can stop some of the record playing and practice it and move another step and another step until you complete. That will be the completion of your homework as well. I do not want you to get too much stressed from this class. Although this is coding intensive course, I want you to, the class itself doesn't give you enough time, but I want you to invest your own time at home, okay, off the class. That is what I ask you to do. Article, maybe one time I ask you to read some of technical papers and do some paper review. That way I want you to catch up the current technologies, okay? Not only the implementation, but also you guys need to learn the trend. Make sure that you should be in the trend that the world goes, right? So many homeworks, at least 5, sometimes 10. One semester project. This semester project this is not group project. This is a solo, individual project. So each one needs to plan what you want to do. One of the mandatory is you have to do that iPhone app. There will be the recommendations. If you want to include sensor technologies with it, that'll be more than enough. Okay? So minimum is if you develop something that can run iPhone only, fine. But better approach is to include some others, okay? Sensors or actuators, or you can, there are lots of RESTful servers available, which is they can provide you JSON data, real-time JSON data. One of the typical JSON data is movie series that currently running on the theater, or train station, Metro North, Amtrak's, or weather data, depending upon your geocode here in New York or San Francisco, whatever. That then there's a server that can provide you the weather data in JSON format. Data scientists, you may be familiar with the JSON. What is JSON?
The kind of format.
Kind of format.
Yeah, JSON, right?
Hmm?
Is that the .json format, right?
JSO, yeah, JS, yeah, JSON, yeah.
Right, and I know that it's a
Okay.
kind of format, but I'm not very familiar with it.
Yeah. So JSON format is something that we are relying most likely. I set up the server so that you can use also. I subscribed on my own, not by the department. We have the server running on the department, but it is dying sooner. So during winter break, I developed the server at the Google Cloud platforms for many other reasons. One of the reasons is this class. So I can set up some there. You may be able to use it. So that can gives you JSON data as you request. I'll give you some of the examples toward the end of this class. So that is, you can see what you need to do, basically, from the demo that we did in another previous class. Okay, so I'll give you a demo. So project, this is real iPhone apps development project. So implementation is a must, but it's not everything. So written document should come with it. So if you develop something, then you have something to write, because that is your work, right? So I want you to write how you develop, how it can be used. So you can make like a manuals for users. I want you to write it that. That is a written portion of your project. So the dominant factor for your project is implementation. But implementation is not 100%. Maybe 25% of those is writing. That is, I know you've done the writing of the project, many other classes as well, very similar to that, okay? So follow these guidelines. As I said, homework 55%, participation 5%, project 40%, okay? No exam, no nothing. Okay, schedule. So first week, today, introduction. And from next week, we are going to work on physics, sensors in physics, or sensor physics. And then we need to set up Raspberry Pi. And then we need to connect some of the sensors to the Raspberry Pi. And then sensor needs to work operations, right? That can be done by Python. So here in this case, we are using Python. Okay, I'm not going to teach you Python. You already have done that. But Python code, excuse me, Python code that handle sensors will be much easier than the coding in Python itself. Much easier. So you do not have to worry about it. Once you studied Python, you will be okay. And also coding list will be provided to you. So we'll do up to these points, all the sensors, only 3 weeks or 4 weeks total. After that, we'll go for iPhone apps developments, Xcode, learning Swift, and then we can develop. Okay, so our plan goes up to 13 weeks, and on 14 weeks, we need to wrap up. Around that time, you guys need to almost done your project. You can bring it if you have any issues. We can discuss all together to solve some of the new issues. So that is a wrap-up sessions. And then the last week of this semester, that is a project presentations. Any question about the course schedules or syllabus?
What is the line?
Clear.
Development and life cycle.
Some of the life cycle will be some of the theory of iPhone apps. Yeah. But basically, we do not only theory in that week. No. Theory very small. So we still continue to do the codings. Okay. But if I do here coding all weeks, doesn't look good. Therefore, I put here, hey, we need to use some of the life cycles, development life cycle. This development life cycle is very similar to software development life cycles.
Is your lecture part? Like
Yeah. Concept. Yeah.
Do you have any specific list for the number 4, the sensors? Like, what are the things that you should be focusing on? Like, if you want to practice something, could you just for the week before we get to know about it or something?
The best practice is this. Motion sensors, motion detector. So your your Python running, your code is running, right? Mm-hmm. So there is a while loop. So it triggers the sensor, motion detection sensors. So depending upon the device, sensor device,
Right.
All different functionalities. So usually what they do is they radiate signals, and then there is a signal reflected somewhere and coming back. But if some object passing through, then we have different returning signals. In that way, motion can be detected. So that needs to be analyzed by your Python.
Right.
Okay, so once motion is detected, then what are you going to do? Many different ways that you can design. One, maybe your camera, about $50 camera. You can attach it. At that time, camera take photo. So camera can take maybe a video sequence or one shot, one frame. Okay. Camera doesn't need to shoot 24/7. Only camera shoots when there is a motion sensed. So take that images. And then another step is send that image to the server, cloud server. That server, we do not, this class doesn't ask you to know about the server. That is another big project. In this class, we do only endpoint.
Okay.
So Raspberry Pi and another displays, which is iPhones, not the server side. Server side, there is another class. But anyway, server side, you can post the data to the server. So server piles up the sensor data from user 1, user 2, user 3. It piled up. Now, next step is your iPhone needs to access the same cloud server and then get the data. You can say, hey, I want to get the data that's taken between this time frame, or I want to get the data posted by user 1 or user 2. Then you can get the data. And next step is how you can display it on your iPhone. Are you going to display it vertically or horizontally? If you see the current smartphones, then vertically so that you can scroll up and down. Horizontally, you can horizontally scroll so that you can have different views. That type of things will be covered, okay? Database issues, lots of database issues involved here because we need to save the data. Image data, sensor data, alphanumerical data. Data may be saved on the server side. I do not ask you to do that because that is another class. So how you can save it on your iPhones, iPhone data, iPhone database. Question to you guys. What is the database names usually available? Comes with small electronic devices like iPhone or Raspberry Pi. What is the name of the database?
It's a SQLite.
SQL, yeah, SQLite. So SQLite comes with almost all microcontrollers. So we're going to use that micro SQLites from your iPhone apps. So as you download from the server, next question is how you can save it on your local iPhones, so that you can use it all the time. You don't have to communicate with the cloud at any time that you want to access. If you save it locally and make it persistent, then you can do it, right? Yeah, that is, I think I explained the whole stream of data flow. So you don't need to do that whole data flow streams, but I want you to think from iPhone side, smartphone side, from your smartphone, how much that you can trace back.
Right.
Are you going to do that all the way down to the other side, Raspberry Pi? And there is also actions, actuator and sensor together. I have some demo for today, so you guys can see it. I want to make sure if it is being recorded. I think it's being recorded, hopefully. See, where is it? It is being recorded. Yeah, it is being recorded. Fine. Sometimes I'm worrying about. As I complete my lecture, and then when I see it, nothing recorded, then it is my stress. Sometimes, if it is a real important, the hands-ons involved, then I go back home and redo. It's very hard to redo. There's a big difference, right? Do my lecture in front of students and do my lecture on my own by myself at night. All different, right? So I'm, all right. So, okay. We can start with the industrial revolutions. Industrial revolutions. We are currently here at the fourth industrial revolutions. First industrial revolution is not way back. It's about 200 years ago. First revolution is mechanical revolution, 1784. System-powered mechanical manufacturing facilities, water or steam-powered. Usually that occurred in what is the name of that Great British, is it? United Kingdom of England? What's the official name around that time? About 200 years ago. The most powerful country at that time is the
British.
yeah, British, right? Great British. Started from there. And then about 100 or 150 years ago, we have electrically powered mass production. So that goes up to that point. England technologies, English technologies. And then third industrial revolution, that is electronics and IT. About not more than 50 years ago, right? There's a first programmable logic controller that makes the manufacturing greatly differently. And then recent years, we have cyber physical systems. Anything that physically being operated can be controlled, monitored, interoperated by computer. Right?
Mm-hmm.
Anything right now. Even that is what I am personally working on these days. Door lock. Door locks, that looks mechanical device, right? Is it really a mechanical device now, door locks? I know many homes, my home also, there's a mechanical door locks. There's no electronics. That is outdated, right? What is advanced door locks?
They use Wi-Fi.
Use Wi-Fi, right? Can be controlled. You can open if you can. If you go to hotel, big hotels, then they usually ask you to choose. Either you want to get the keypad, the card, or you want to install the key on your smartphones, right? They ask you. So around the time you arrive the hotel, then depending upon your choice, you may have the key that is activated on your smartphones. So if you approach to the hotel door, and then there is a apps, so you can click the button so they can be opened, right? Also, the lock is not just only open. I would say carefully, it's not only unlock, or is it even further, open it. Some locks, they can be unlocked by your smartphone. If it is unlocked, then you can use your door knob so that you can move it, and then you can push or pull the door. From that point, that is actuation, right? From that point to even advanced actuation is, if you open it, then physically opened it, right? Not only unlock it, but open it for you automatically. There's actuation, right? And then when you pass it, automatically close and lock. So lots of different sequences available, right? So AI and mobiles, recent days, about 2 weeks ago in Las Vegas, it's a CES. Anybody's visited the CES
What?
in your life?
I haven't, but I watched.
So you can see it, right?
Yeah.
Lots of. So this year's main topic is artificial intelligence and mobile. That is in CES stands for Consumers Exhibitions, Consumers Electronics, maybe. It originally started from New York, 1960 some years, and now that is annually. Gather together in Las Vegas once a year in January. So this year, I wanted to watch this together.
From LG see-through TV to the first car equipped with ChatGPT, the world's biggest electronic show continues to bring us extraordinary tech. Here's what are, in our humble opinion, the best products from CES 2024. CES never fails to surprise us, and this year's unexpected trend was transparent displays. There's something you have to see to believe, or I guess see through to believe. LG introduced a 77-inch transparent TV called the OLED T. The idea is it's supposed to blend in with your home when you're not using it by transforming into, say, a fish tank or a window to a starry night, rather than taking up space as a boring black screen. I am not sure how much blending in it'll be doing. It's far too cool looking to go unnoticed, but it sure does open up the room more than a black screen would. You can watch TV in that transparent mode, but the screen can also become opaque for a more traditional viewing experience. It only has one power cord, which is great because it would kind of be a buzzkill if you could see lots of cables through your transparent TV. You can plug any other connections into a separate box that can sit up to 30 feet away from the television. Pricing hasn't been set, but CNET's David Katzmeyer expects it to be very expensive. It's supposed to be available sometime this year. Samsung also introduced a transparent version of its micro LED screens, but we probably won't have this tech in our homes anytime soon. One, because it isn't available in the market yet, and two, because the demos highlighted more commercial applications. Imagine the windows in a luxury box at a sports game being made out of these micro LED screens that you could see through and see useful information like the score on. Pretty neat, even if it's still a concept. AI was the buzzword at this year's CES, which isn't surprising because it's the hottest topic in tech right now, and because, to be fair, a lot of the companies that present at CES have been talking about it for years. But at CES 2024, we saw some of the major AI advancements from the past year, like OpenAI's ChatGPT, being integrated into our everyday devices. Maybe the most significant came from Volkswagen. It announced it'll be adding ChatGPT to its electric vehicles in Q2 of 2024. More specifically, the car maker is collaborating with Cerence to add the chatbot into its IDA voice assistant. Right now, you can ask IDA to, for example, place a call or navigate you home, and tasks like these will continue to be handled locally by VW's software. But starting in Q2 of this year, IDA will be able to answer more complicated questions with the help of ChatGPT. Say you want some good fettuccine Alfredo. Instead of asking IDA for Italian restaurants nearby and figuring out which ones have fettuccine Alfredo on your own, you can just ask IDA, where can I get a good fettuccine Alfredo nearby? And the voice assistant will find the restaurants with the dish for you. Rabbit's R1 uses artificial intelligence to take scrolling out of using your smartphone. Just press a button, speak voice commands into it like a walkie-talkie, and it operates the apps on your phone for you. So you could ask it to, for example, play a Spotify playlist on your phone or call an Uber. It's $200 and is currently available for pre-order. This is the flip phone like you've never seen it before. Meet Samsung's Flex In and Out Flip. It bends 360 degrees so you can still use it when it's shut. It doesn't block the camera even when it's flipped backwards, and the larger side is big enough to show useful information like battery, the time, media playback controls, and more. It's still just a concept, but it's pretty cool, and CNET's Lisa Edachico points out that this could give us a glimpse into the future of foldables. The EV ring may look like a regular piece of jewelry, but it's actually a smart ring designed specifically for women. It tracks a period, ovulation, menstrual symptoms, daily steps, active minutes, sleep, mood, and more. CNET's Bridget Carey used it while running around CES and liked that it was an unobtrusive way to just track her health, and then she could check her data from the mobile app. She said it did well counting her steps, and unlike her Apple Watch, she could sleep with it without worrying about the battery dying overnight. You can order the EV ring now for $270. It doesn't require a subscription, but it is iOS only right now. There's never a shortage of cool new laptops at CES. ASUS unveiled the ZenBook Duo, the brand's first laptop with two full 14-inch OLED touchscreens, giving you lots of screen real estate. We saw a design like this last year and highlighted it as one of the best products of CES 2023, Lenovo's YogaBook 9i. But the ASUS laptop offers two welcome improvements over Lenovo's: a detachable Bluetooth keyboard and a built-in kickstand for the laptop. You can also lay the ZenBook Duo flat and use it with the ASUS Active Pen. The performance specs are pretty sweet in the ZenBook Duo as well, with up to an Intel Core Ultra 9 processor, integrated Intel Arc graphics, and up to 32 gigabytes of memory. ASUS says the ZenBook Duo will be available sometime in Q1 with a starting price of around $1,500. Those were some of the best products of CES 2024. For more cool tech and our favorite finds from the show floor, subscribe to CNET. From
Okay, so AI and mobile sensor connections, and also software-driven X. That is another the important concept. Discussed in this year's CES 2 weeks ago. What that means is that if you want to make something X, then that X can be driven by software. For example, automobile, vehicles. Traditional concept of vehicle is you can make the vehicle first, and then you can add tire, engine, all of those, right? So new concept is you develop software first, and then we can put 2 tires, 4 tires, and then some of the metals outside. Then it can be a car, which is a Tesla right now, right? Start from the software. It's not start from physical devices, but start from the software. There's a software-driven X. You can think of any X. Another video that you can see also
In
from
terms of the presentations. One last thing I would like to say is ARM is hosting an automotive partner summit in Cambridge on the 26th of October.
oh, this is
The last 2 iterations that you see on the right,
I want to jump
basically-
something here. Distributed domain. Let's see. Here is what I want to do. From here, I said here, watching point for scaling computings, 11 minutes. Watching points for, what does SoC stands for? So, software on chips. 28.5 minutes, and watching points for 4 foundations, 30 minutes, my typo. So you can jump if you want to see some of the keyword, some of the technologies on your own. I'm going to skip this. And then software-defined the mobiles. I wanted to check out this. So let's see what it does have.
I'm here at CES 2024, and we're taking a look at the best mobile tech that I've seen at the show. First up is Samsung's Flex In and Out Flip. Now, this concept basically looks like Samsung's Galaxy Z Flip phones, but instead of only folding inward, it actually folds backwards as well, so that the screen can be used even when the device is closed. Next, we also really loved the Asus ROG Phone 8, which is Asus's newest phone aimed at gamers. So this phone really stands out. In addition to its gaming-specific features, it has a large battery, super fast charging, and a really high 165 Hz refresh rate. Next, we really loved the Clicks keyboard, which essentially adds a physical keyboard to your iPhone. So if you had a BlackBerry at some point and you miss your BlackBerry, this keyboard is designed to recreate that experience. We also really liked the TCL 50 XL Next Paper, which is the first time the company is bringing its paper-like screen to devices launching in the US. It's not going to replace your Kindle exactly, but it does provide a lot less glare. So if you're outside and you frequently read in bright sunlight a lot, this phone should be much easier on the eyes, and it also should be a lot easier to see. Another really fascinating gadget here at CES is the Rabbit R1. This device isn't a smartphone, it's actually trying to be an alternative to your smartphone. It's a tiny pocket-sized device that kind of looks like a retro gadget with a really tiny screen with a push-to-talk button that you can press to ask specific tasks. Because this device runs entirely on AI, there are actually no apps. It connects to your apps, but there are no apps on the device itself. So it's a really fascinating look at the types of new AI products that companies are trying to create. Another thing that really stood out to us at CES is the Double Point Wow Mouse app. So this is an app for Wear OS smartwatches, and it basically turns your watch into a controller for your laptop, really anything that you can connect a digital mouse to. But at the demo that I saw, they also had it hooked up to a lamp so that you can turn the lights on and off just by moving your hand. It felt really cool, it was really interesting, and it was definitely a highlight of the show. So those were some of our favorite mobile devices we saw here at CES. Don't forget to
So Industry 4.0, there's a 4 major concepts involved. Awareness. So your device can aware the environment. As a human, we have only 5 senses, right? See, smell, hear, 5 senses, some of the 5 senses. But five senses are not enough, right? If you go to deep in the mountain, then you may be able to see so many hikers walking together with the dog, right? Why they carry dogs? Dogs can hear something that we may not hear, right? Dogs can see if there is any animal that can attack, possibly, then your dog can identify that a lot faster and easier. That is another sensor, right? So the sensor that we have, as we originally created, is not enough. Therefore, but human knows how to develop the wide range of sensors, right? Hearing can wide range. View, we can see only something in visible frequency ranges, right? In other words, we cannot see something dark at night. If you see the frequencies of the lights, then ours is, we humans' eyes can recognize from red to purples. That is frequency ranges. Above the purple, then we can say ultraviolet. Lower the purple frequency range, we call that infrared. Therefore, there is a camera developed that can take the dark, any objects dark at nights. We call that infrared cameras, right? Because our eyes cannot see, our eyes are limited to see only that frequency ranges. Although frequency range is wide enough, we cannot see something X-ray. If our eyes can see X-ray, then I can see your bones. Because our eyes cannot see your bones, our doctors, human doctors, cannot see your bones. Therefore, we have X-ray device, equipments that can take the images from your those, right? So lots of those. X-ray is high frequencies, a lot low frequencies, like our acoustic, sonic, our vocal frequency ranges, right? So we can say something, we can hear something in that range, acoustic ranges. So a little above that, we call that ultrasonic. So ultrasonic is like our vocal frequency ranges. Ultrasonic can be used in many devices, like motion detections. Then we use ultrasonics. If we use laser, then it can go even further, very fast. So usually highway patrol police officers uses the laser gun, which is the concept very similar to ultrasonic motion detection and X-ray laser guns for your speed checkers. So ultrasonic widely used in medical side as well. Yeah, there is awareness. Another thing is intelligent. One below here, intelligent. That is currently very, very hot topics, how you can make intelligent. What is the difference between artificial intelligence and your typical codings? Even further, if it is machine learning, then what is machine learning coding and your typical programming code, the Python codings? What is the difference between those two? Machine learning is a data-driven. Your coding is logic-driven, right? So you first design and define the logic, and you codify it. That is your codings. That's what we are going to do in this class, logic-driven codings. We're not doing machine learnings in this class. Connection is another big issue. Your iPhone has 4+ antennas embedded. First antenna that you can see is cell signals, so that your cell phone needs to communicate to the cell tower. That is one antenna. Another antenna installed on your cell phone is to communicate with your Wi-Fi signals. There is another antenna. Wi-Fi signal needs to be identified, recognized. Cell signal needs to be recognized. What others? Bluetooth signal needs to be recognized. There's another antenna. What is the fourth antenna? GPS signals needs to be recognized. Therefore, geocode can be identified by your cell phones. What are the possible? Sometimes, few years ago, some other phone manufacturers embedded a fifth antenna, which is ad hoc communications, like Z-waves. IEEE 15.1, that is Zigbee, 15.4, that is Bluetooth, and lots of IEEE 15 or 16 different types of signals needs to be identified, because those signals has been used in medical equipments a lot. So once one cell phone manufacturers include that on the smartphones, but not anymore, because if it is the case, then what happens? If you go to hospitals, then you can identify some of the signals, X-ray signals, to communicate to another the server. You can interrupt it, you can take it. So anyway, in the future, more signals may be received by our smartphones, but currently, usually those 4 signals are received by smartphone that we use, right? There's a connections. Responsive. Autonomous production, adaptations, and internal and external commands, some of the actuations that needs to be done, right? So 4 things are fully equipped, then that is industrial 4.0. So impact of industry 4.0, service models, business models will be changed or upgraded. Reliability and continuous productivity improved. IT security ensured. machine safety monitored, product life cycles, industry value chains, workers, socio-economics, industry demonstrations, and more and more. So new paradigm is we are sensing and actuating and learning. That's what we are doing. This is a paradigm of this class, not the industries. And your future, the work application is the smart building. You can see so many things, so many smart things in building, your home as well, your car, of course. AC power submeters, gas meter submeters, gas and water submeters fully equipped in just New York areas, right? All the gases, all the waters are automatically, the data can be collected. So if you want to hack into that collect devices, there's worth. No, don't try. There's possible things because they are all connected wirelessly. Temperature in humidities, light, CO2 sensors are fully equipped. Outdoor temperatures, relay node, routers, they're all connected to the internet. Smart manufacturers, dynamic plant configurations and readiness, dynamic product configurations, dynamic inventory minimizations, all should be monitored. What that means is that there should be sensed. Sensor data needs to be acquired and properly analyzed, and therefore plan to mitigate any issues and improve the functionalities and serviceabilities. That's what we need to do. Something that we can see these days, that is the smart vehicles. Some of the things that I want to share, this is something that, this is one of the key locks, right?
Okay, this is the lock.
I want to jump
my
in.
cell phone. Try to connect. It's now connected, and I want to open this door. Currently, this is locked, and when I press, for example, number 1 for open, send, and that is open. It's completely open right now. And in this case,
This is an actuator, right? From my cell phones, it goes to the router. From that router to this, there's a Raspberry Pi somewhere. Let's see. Yeah, this is a Raspberry Pi. There's a connections to the lock. Okay. Let's see. Oh, more videos. Yeah, I have more videos. I want to share that with you. Quickly, how actuator can work. This is a lock. This is a
Alright.
smart
This
lock.
is a Yale motor lock. This pushed here to lock. I mean lock.
You
yeah.
guys never
And
seen
then,
this, right? This
pushed
kind of
back,
locks.
That's unlock.
So most of
this
the,
is a
the
Yale lock.
expensive hotels
And
equip them
Yale
with
lock
this kind
has
of locks.
an outlet here, all the way here. So we're going to use only the motor operations. All other the sensor operations is not handled at this time. The sensor here, and also sensor here, and 3 sensors, and 1 motor that is lock and unlock. That is now controlled. So that is connected all the way here to this H bridge relay modules. That is now controlled by here Raspberry Pi, and power is supplied from this AC to DC converter, and that is now programmed here on this one, and I'm going to run this code, Python rcmotor.py, and I hit enter, and when I type so whatever the either 0 or 1, so type 1 and hit enter, see what happens. It is 0 means unlock, so that is now unlocked. And now I'm going to type number 1, which is a lock. Hit enter. That is locked. And then enter 0, then that is unlocked. And enter 1.
There's 1. And the other one that I can show to you. Remember that here, this is locked and unlocked. This is connected with the door knob. If this is unlocked, detached, then this can be moved. This can be your doorknob can move the spin, right? Not spin. It can moved. Therefore, your door bolt can be moved out. The other type of the thing here, I explained it here in my language, Korean, so you don't have to read it. Or you can read it. You can hear, although you do not understand.
안녕하십니까. 지금은 그 밀레
No, not this. I didn't. Yeah.
그 몰티스 락, 몰티스
I'm now
락을
explaining in
그
Korean
회로,
languages. So.
똑같은 회로에 연결을 시키고 작동을
This is the same
해보겠습니다.
circuit, exactly the same ones, but different locks. Remember the other ones here, you have to include, you have to door knob here. So you have to turn the door knob to open. But in this case, a little more. You can,
또 제로를 치면
you don't have to turn the door knob because this guy
이렇게 작동이
open it, right?
원활하게
Not only unlock but open it.
할 수 있습니다.
If you use this kind of locks.
감사합니다.
These are other things. And then there is a, remember that door, if you look at that door on top, there is some of the hinges that can pull and push.
Right.
So that can be also controlled. So what happens is that if you go to busy areas like hospitals, then you can carry patient to surgery rooms So time is very, very important. Although, and all different sectors are locked completely for many reasons in hospitals, right? But if you want to use it and turn the doorknob and push to open, it time delays, right? So ideal way is that if you are right person, you carry your cell phones, smartphones. As you push the patient, then the door recognize you and open it. So you can carry the patient all the way to the surgery rooms. Okay, so different levels of actuations possible. Okay, for directly related to this class. So coding will be done here. This is Xcode. This is an emulator. This emulator is very similar to your phone, right? So we're going to use a Swift and Xcode. I believe current version of Swift is 5. But anyway, this is Swift. That is the language. And that can be deployed in your smartphone device or your TV or your watch, right? Apple Watch. Xcode can be downloaded. If you do not have Xcode on your MacBook, please download and install it. If you do not have a MacBook, then you can subscribe to Mac in Cloud, as I showed to you, so you can use it. The version is maybe upgraded right now. And IoT, we're going to use here, this is a Raspberry Pi. So we start with the Raspberry Pi and connect some of the sensors and actuator. Here we have the pins, right? Pinouts. Raspberry Pi has 40 pins available. So you can connect wire from here to one of those pins, and your Raspberry Pi, your Python can define, hey, I want to use this pin to receive the signals or send out the signals. That type of things needs to be defined on your Python code. That is given to you. Do not worry about it. But once you know it, you can clearly see, oh, sensors can be operated that way. And then your Raspberry Pi has already Wi-Fi connections. Then Wi-Fi can communicate with the cloud server. Remember that this cloud server will be designed by me only at this point. So this class will cover only here, the bottom, the yellow region here. So this is the posting components. This is downloading components. So you can communicate. Your cell phone needs to communicate with the cloud servers, and then display it. This is app. So paradigm that we need to do, and also you have to consider this for your project, how you can post the data to the server, how you can download it, how you can visualize it. So posting, downloading, visualizing, posting, downloading, visualizing. So that paradigm needs to be kept in mind and see how you can maximize your visions. Two primary things that you need to do. Sensing what human cannot sense, so using some of the sensor technologies, because human built-in sensors are limited, as we know already. And actuations, our actuation is very, very limited. 2 hands and 2 legs. And also some of the cameras, some of the speakers, right? A lot more. Our human actuator, we do not have a motor, right? Although we do sometimes dance, but we do not rotate 5,000 RPMs, right? You know what RPM is, rotate per minute. How many times that you can rotate when you do dance? Maybe me, 2 times of rotates. Younger, maybe 20 times. What human accesses? Human can access only smartphones. Demo that I am going to do here, what is this? Yeah. Okay, I'm going to demo after I explained this. This will be your first homework assignments. I already posted. Design your architecture of a mobile tech. Mandatory the iPhone. iPhone apps needs to be done, needs to be involved. Sensors, optionally, but highly recommended. If you see the demo, then you may feel much clearer what you need to do. Coding sketches, that needs to be. This is the outcome. This is what you need to submit for homework assignments 1. For example, UIs, what you want to display on your smartphones. Sequence of views needs to be drawn. So I want you don't need to draw that on your Xcode. You can use any computer drawing tools, or maybe PowerPoint, and draw some. What you need to draw that you can see, I'm going to show to you on demo. And that, between the views, you need to specify what data needs to be passed, what data needs to be received from one view to another view. View in this iPhones, view is nothing but the display on your smartphones. Most of the apps running on your smartphones, there are more than one views, right? If you click one button there, then next view comes up. There you can click something, then next view comes up. You can come back to the previous views. So among the views, data needs to be passed from one view to another view, and then received it. That type of things needs to be done. As I said, iPhone side, that is a must, that is a mandatory. So you have to do this. If a sensor involved, then what kind of sensor data needs to be used? What data needs to be posted on the cloud. Therefore, it can be displayed on your iPhone. So you need to do this together with the description of scenarios. Because I do not understand what you are going to do without the scenario descriptions. I want you to describe what you want to do. So now I'm going to give you the demo. These are the files. So we're going to use storyboard approach. iPhone developments, 2 kinds of approaches, basically. storyboard or purely coding itself. We call that Swift UI. This UI is UI kit. So either you can use a UI kit or Swift UI. In this class, we're going to use UI kit only. If you use a UI kit, then here storyboard, if you click main, then you may be able to see the views. This itself is one view. I have multiple views here, right? You can start from here. And depending upon which one that you clicked, it goes to either there or here and even further. So first homework assignments is, I want you to draw something like this. This is one view. You can say this is some of the text field, some of the guidelines, some of the buttons, and from the first view, if you click this circle, then it goes to where. Next view, clicks this and goes to where, right? And same thing here. You have a multiple of the rows, like a table formats. We call that table view. Click one of the item in that table views and goes to next, and bring up some of the images and also another table views. And finally, it goes to larger images and another text field, so that you can ask comment on these images, and that it can be saved. And when you come back here, then previously saved comments may be able to be displayed. So this kind of scenario needs to be planned. Please do not try to do all details. I want you to do roughly at this point. I gave you 2 weeks, right? 2 weeks may be enough. So we have one more week next time. So if you have any question, you can bring the question next week. Any ambiguities needs to be cleared out, okay? So I have a code here. This is one code. This is all the code files, right? To run this kind of Xcode, there's emulators. Currently, we have here iPhone 15 Pro. You can change it. Yeah, I didn't download much, but 15. Currently, what is 16? iPhone. What is the version of iPhone right now? 16 or 15?
15.
Oh, 15. This is most recent. So we can choose the emulator, and if you click this triangle, then it can run. As it runs, if you plug your iPhones to MacBook, then you can see your own device here. When you click this, then you can see your own device somewhere. But I didn't attach that, right? So this is emulator, and run it on the emulator. So that is successfully basically this is two-factor authenticators, access controls. Just the simulations, right? 62, 72, these are automatically randomly generated. And I can put here John, oops. What is this? Why this is still there? I want to redo. My mistake. Wrong button clicked. Okay, 99.25. So John. All right. And you can log in. How many buttons? I have 3 buttons here. Login that uses local database, SQLites. So we're going to learn that later. Or we can use user authentication from remote cloud servers. If you click this, then it goes to the server and find out this is the right person to admit. I'm not sure. I'm not sure which ones that I need to do. Let's try login. Okay, here. What was it? 9925. 9925. Verify me. Oh, it's not recognized. Let's go to remote. 9972? 9925. Oh yeah, it is recognized. So server has different ones and local has different. This is just my implementation. Oh, this is unclickable. This is not clickable. It's not authorized yet. I don't know. I don't remember the password. So let's do replace. So without authentication, simply let's try to do open. John, Yoon, open. Oh, okay. So this, some of the students' works there, right? So previous students. So it shows you last name, first name, number of sensor data posted, 5 sensors, number of images posted will appear when clicked. So remember there is a small lines. There's one item, there's another item, and another item. There's a vertically scrolled. So if I click mine, then it shows you horizontally the images that I posted. So this is me. So let me click myself. So if I click me, I'm here. So please make a notes. My previous notes here. You look good. So I said, you are frustrated. Save it. Is it saved? Go back. Let's see. Oh, I clicked it 2 times, right? You are frustrated. You are frustrated. No worries. Save. Go back. Click me. No worries. This type of things, right? So here, let's see if there's any good ones. 필요해서. Yeah. So sometimes it goes to local database. Sometimes it goes to the server side credential database. And if you click this, then it goes to another database. Therefore, it shows you, oh, this is beautiful. I didn't see this. This is a local from the local database. All right, so this type of things may help you enlarge the future fusions so that you can implement it partial in this class, and then you can take it with you after this class to do some great work. Okay. So I want you to make some of your dreams in the mobile technologies. Do not make it small, big visions. It doesn't mean that you have to implement that big vision in the next 3 or 4 months. I want you to make it big vision, but small implementations in this class. Any questions? All right, then this is it. I'll see you next week.
About the book you mentioned, we didn't
Yeah.
have to follow the book too much.
No, I'm not going to. We're going to cover most of the coding list there, but not page by page.
Okay.
Yeah. Any question, Hanok?
No, everything is clear. Thank you.
Okay. Thank you. See you next week.
See you.
Have a good